November 1921. Joseph Strauss walked into San Francisco City Hall carrying one blueprint and one promise. He could bridge the Golden Gate, the most violent stretch of water on the Pacific coast. 60-mile-per-hour winds, currents strong enough to drag fully loaded cargo ships sideways. Bedrock buried under 100 feet of open water and 25 feet of shifting sand. The U.S. Army Corps of Engineers had formally declared the project impossible 2 years earlier. The world's most respected bridge engineer called it suicidal. Strauss stood 5'3". He had never built a suspension bridge. He had 13 years, $35 million, and a secret he would carry to his grave. 11 engineers had come before him. Every one of them studied the Golden Gate Strait, ran the numbers, and walked away. The tides here reverse 4 times a day. Fog rolls in from the Pacific so thick that ships have collided at anchor. The 2 headlands Strauss intended to span, Fort Point on the south, Lime Point on the north, stand 4,200 feet apart across water that never calms. In 1919, the Army Corps of Engineers delivered its verdict in writing. The Golden Gate could not be bridged. The forces exceeded anything structural engineering had yet solved. Strauss read the report, then he ignored it. He had been trying to build this bridge since 1916. For 5 years, he had lobbied San Francisco city government, attended public hearings, revised proposals, and absorbed one rejection after another. Engineers dismissed him. Financiers turned him away. Military officials argued that any fixed crossing would be a strategic liability, a single point of failure that an enemy navy could destroy, sealing the harbor permanently. Strauss kept coming back. By 1923, he had enough political support to trigger a formal feasibility study. By 1928, a bridge authority had been established. By 1930, the financing was in place. $35 million in bonds to be repaid by tolls. The final authorization went to a public vote across 6 counties. In Marin County, the measure passed by a margin of exactly 1 vote. 1 vote. That single vote handed Joseph Strauss the most complex engineering project in American history. And Strauss was not a suspension bridge engineer. His original design was a hybrid. A cantilever structure on the south end, joined to a suspension span in the middle. A form no one had built at this scale, in these wind conditions, against these tidal forces. 2 structural engineers reviewed the plans privately in 1930. Both arrived at the same conclusion. The design had a fatal weakness at the junction between the cantilever and suspension elements. Under the dynamic loads the Golden Gate Strait would impose, wind oscillation, seismic movement, thermal expansion, that junction would fail. Nobody said this publicly. Not yet. Strauss had hired Charles Ellis in 1922. Ellis was a professor of structural engineering at the University of Illinois, one of the most respected bridge theorists in the country. Strauss needed someone who understood suspension bridges. Ellis was that person. What happened over the next 9 years would not become fully known for half a century. Ellis didn't consult on the project. He took it over. He corresponded with Leon Moisseiff, the engineer who had designed the towers for the Manhattan Bridge, to understand how long suspension spans behave in variable wind. He ran calculations on wind loads, cable geometry, tower stress, and deck behavior. He designed the main cables. He specified the anchorages. He determined the tower height. He worked through the structural problem that Strauss's original hybrid design could not solve. And he solved it. The solution required abandoning the cantilever component entirely. The bridge would be a pure suspension span. The aerodynamic profile of the deck would be deepened. The main cables would carry loads no American bridge had ever asked of steel wire. Ellis spent 11 months in Chicago producing those calculations. Hundreds of pages. The structural foundation of the bridge as it was actually built. Everything that makes the Golden Gate stand came from those pages. In December 1931, 2 years before construction was scheduled to begin, Strauss fired Charles Ellis. No public explanation was given. Ellis had been working without pay for several months, still refining the final structural specifications. Strauss terminated his contract, recalled all his papers, and removed his name from the project files. The calculations Ellis had produced were attributed to the engineering firm Strauss had on retainer. Ellis's name disappeared from the construction documents. It disappeared from the press releases. When the bridge opened in 1937, it was not on the dedication plaque. Ellis went back to teaching. He never spoke publicly about what had happened. The Golden Gate, the work of his career, opened without him. Here is the question nobody asked at the time. If Strauss fired the man who designed the bridge, what exactly did Strauss contribute? A pure suspension span of 4,200 feet had never been attempted in a seismically active zone. The towers would need to be founded directly in the water, one of them 1,125 feet from shore, in 65 feet of open Pacific. Building that South Tower foundation required constructing a concrete fender around the site, pumping it dry, and working inside it while the ocean pushed against the walls outside. Workers operated at the edge of what the engineering and the equipment of 1933 could do. Construction began in January of that year. The South Tower foundation was the first crisis. The concrete fender leaked. Pacific swells up to 15 feet broke against it during winter storms. Divers worked in near-zero visibility to plug the gaps. The North Tower rose first, its bedrock close to the surface on the Marin side, its foundation clean and fast. For months it stood alone, a 746-foot column of steel visible from miles away, with nothing to hold. The main cables were the next frontier. Each cable would contain 27,572 individual wires, wound into 61 strands. Each finished cable would be 36.5 inches in diameter, roughly the width of a dinner table, and carry a live load that the engineering team calculated, recalculated, and calculated again. The spinning process took workers out onto the cable lines in open air, at height. They walked catwalks, wire mesh platforms suspended between the towers, in the fog, in the wind, in temperatures that dropped below freezing at elevation. The catwalk swayed. In strong winds, they swayed more than a foot in either direction. A safety net had been strung beneath the roadway deck, 17 feet wide, extending 10 feet beyond each side. It cost $130,000. It was the first large-scale construction safety net in American history. 19 men fell. All 19 were caught. They called themselves the Halfway to Hell Club. 11 others were not caught. February 17, 1937. 10 weeks before the scheduled opening, a moving scaffold carrying a work crew broke loose from the deck. It tore through the safety net. The platform and the men on it fell 220 feet into the bay. 12 men went into the water. 2 survived. The project foreman filed the incident report. The bridge authority reviewed it internally. The opening date did not change, and when Joseph Strauss stood at the podium on May 27, 1937, and accepted the honors in front of 200,000 people, the deaths of February 17th were not mentioned. The dedication plaque named Strauss as chief engineer. It named the consulting engineers, the financial officers, the members of the Bridge District Board. Charles Ellis's name was not on it. The bridge opened to pedestrians on May 27th. 200,000 people walked across before a single vehicle passed. They walked through fog that had burned off by mid-morning, across a span that 6 years earlier the most experienced engineers in the country had declared physically impossible. They didn't know about Ellis. They didn't know about February 17th. They didn't know that the design Strauss brought to City Hall in 1921 would have collapsed. What they knew was that they were standing on something the world had never seen. 200 feet of suspended steel, rising to towers that cleared the fog line, connecting 2 headlands the bay had kept apart since the last ice age. The photographs from that day show people walking slowly, stopping, leaning against the railing. There's something in the images that doesn't look like celebration. It looks like disbelief. Strauss died 14 months after the opening. He was 68 years old. He had spent the final year of his life collecting awards, delivering speeches, and writing a poem about the bridge that was engraved in stone at the south end. The poem is about vision. It is about one man's refusal to accept limitations. It does not mention engineers. The bridge itself continued doing what Ellis had designed it to do. It carried 9 million vehicles a year. It survived the 1989 Loma Prieta earthquake, a 6.9 magnitude event that collapsed a section of the Bay Bridge across the water, without structural damage. It swayed 27 feet at mid-span during a windstorm in 1951. It held. In 1949, the University of Illinois awarded Charles Ellis an honorary degree. By that point, Ellis had spent 18 years teaching structural engineering with no public acknowledgement of his greatest work. His students knew the Golden Gate calculations existed. Some of them had studied the documents. But the history books said Strauss. The newspapers said Strauss. The plaque at the south end said Strauss. Ellis accepted the degree quietly. He died in 1949, the same year it was awarded. He never saw what came next. 40 years passed. In the 1980s, a structural engineer named Stephen Cassidy began researching the history of the Golden Gate for a book. He found Ellis's correspondence in the university archives. He found the calculations. He found the letters between Ellis and Moissaieff that documented month by month the actual design process. He found Strauss's termination letter. What Cassidy uncovered wasn't disputed by anyone who reviewed it. The paper trail was complete. In 1995, 58 years after the opening, the Golden Gate Bridge Highway and Transportation District officially recognized Charles Ellis as the primary engineer of the bridge. A plaque was added. His name appeared in the record. The corrected history didn't erase what Strauss had done. He had fought for 13 years to build something when no one else would fight for it. He had secured the financing, absorbed the political opposition, and forced the bridge into existence through a combination of persistence and ego that may have been the only thing capable of getting it done. Without Strauss's refusal to accept the Army Corps verdict, there is no bridge. But without Ellis's calculations, there is no bridge that stands. That is the distinction the dedication plaque missed in 1937. It took 58 years to correct. The question worth sitting with isn't about credit. It's about what a structure actually requires to exist. The Golden Gate needed someone to believe it was possible before the math said so. It also needed someone to make the math work before a single ton of steel went up. Those were two different people. Today, the bridge carries 10 million visitors a year. It is painted international orange, a color the consulting architect chose because it remained visible in the fog and complemented the headlands. The US Navy had wanted it painted black with yellow stripes. Strauss wanted gray. The architect's choice prevailed. It's the reason the bridge photographs the way it does. The main cables have never been replaced. The original steel wire, spun in 1935 and 1936, is still in place. Engineers inspect it by drilling small bore holes and inserting probes to check for corrosion. The wire is holding. The Halfway to Hell Club held reunions for decades. The last known surviving member died in 1996. The bridge has survived 87 years of tides, earthquakes, windstorms, and fog. It has outlasted the political disputes that nearly stopped it, the design flaws that almost sank it, and the institutional erasure that buried the name of the man who made it possible. Charles Ellis spent 11 months in a Chicago office running calculations for a bridge he would never be credited with building, for a man who would fire him before the first shovel went into the ground. He got his plaque 58 years late. He didn't live to see it. The bridge he designed is still standing. Some things survive what was done to them. At Monument Reborn, we go behind the photographs and find what it actually cost. In time, in lives, in decisions no reasonable person would have made. What monument do you want us to uncover next? Have you ever stood on the Golden Gate and felt the weight of what's buried in its history? Tell us in the comments. Subscribe to join us as we bring the next impossible structure back to life. There are more bridges to cross and more erased names to find.